Morning everyone. Today we are going to discuss about mechanical working of metals, which is Unit 2 in the subject 18 MEC 103P. I am Dr. Vijaya, Assistant Professor, Selection Grade in the Department of Mechanical. So these are the syllabus we are majorly going to cover in the Unit 2. It starts the introduction to hot working and cold working and the different types of the process in the hot working and cold working, namely ruling, forging, wire drawing, extrusion, bending and forming, and the types of dies and the defects involved in that. So learning outcome, the objective of this course at the end of the unit, the learners will be able to identify what is the metal forming process and the sheet metal techniques applied to do any fabrication work. And this is a learning assessment, and one can see that 30% of questions will be involved in the level 1, Bloom's level, that is just remember and understand, and 40% of the questions will be asked from analyze and apply, and the remaining 30% is the advanced level 3. So at the end of this unit, the learners are expected to answer the following questions. Examples, you must be in a familiar way to differentiate between casting and metal forming, and what are the advantages of the metal forming process over the casting, and what are the different types of metal forming process, and various sheet metal operations, and what are the machine tools required for that, and to do the blank size calculations and compute some drawing force and bending force involved. So let us first see. In the unit 1, we might be discussing about the casting process. So the unit 2 mainly focuses on metal forming. What is the basic difference between the casting and metal forming? As you all know, casting is a process in which molten metal is poured into some mold or a cavity in order to form some shape. Whereas in metal forming process, what we are going to do is we are going to consider a billet or slab, and by applying a force, mechanical force on it, we are just bringing the existing billet or ingot to the desired shape. So that's the difference, main difference between the casting and metal forming. So we can see this. Can you identify what is a casting and metal forming process in this slide? The first one on the left hand side, we are seeing the mold cavity, and here in the ladle there is a molten metal is there. So it is obviously a casting process. After pouring a molten metal into the cavity, you can see that. Whereas on the right hand side, you can see a person who is working on the billet. Okay, so that billet is also in the red hot condition, but he is applying a mechanical force over it. So basically, these two process, they are not involved in any metal removal process. For example, you take a machining process. It is if you want to get some product, you are going to remove the unwanted material layer by layer in the machining process, what we are going to discuss in the next unit. Whereas the casting and metal forming process, we are not going to remove any metal material. We are just converting the metal in one form to another form. In the casting, from a liquid state, that is in the molten state, to the solid state. Whereas in the metal forming process, from solid state to solid. Just by applying a mechanical force, we are just changing the cross section of it. Let us see. See, you can see, you must be aware of this image on the left hand side. So it is one example for metal forming process. So they are heating the metal to the red hot condition, and just by beating it on the anvil, and then they are changing the shape of it. So we can say this heating the metal above a certain temperature and work on it by applying some mechanical force. So this is what we used to call it as a blacksmith. In the earlier, it is one of our tradition where the people used to do the ornaments or blacksmithy work. On the right hand side, you might have seen the logo of Forged in Fire. It is one of the famous TV show in the history channel, and there it is a competition for the blacksmithies where they are making the knives and swords they are using, if you are watching that, it is very easy for you to follow about what are the procedures they are following, how they are forming the knives and swords from the available steel or bin bar. Whereas the lower bottom one is the it's a casting process where the people are melting the metals to form the molten metal. So you can see some small video here how the people used to make the horseshoe. It is one kind of metal forming process or a smithy, where you can see that these are all the different tools they are using it. This is the different shapes they are forming it. And you can see this in an open hearth furnace. It's just heating it and then beating to the required shape. So that's the anvil he is using as the reference. Now he is heating the metal. So what is the advantage of heating the metal? Because the yield strength of the metal is decreased when you are heating the metal, and then the ductility is increased because of that. That's why the people are heating the metal with a certain condition, and then he is applying using a chisel. He is just applying the force on it to make some shape, just creating a groove on it. So in olden days it is not a so accurate process, it is a manual process. So nowadays, suppose you are going for this forging process, it is a closed one. In the industries, manufacturing industries, people are following the process and all to apply a force. It is a very crude method. He is making a nail driven through it, and again he is flattening that. So he is repeating the process. He is again heating, and then so here you can see there is no metal loss in it. He is just reshaping the metal. And at last he is putting it in the water. This is called a quenching process. In order to improve the strength, he is doing that. So now he got the horseshoe ready. So I hope you understand now what is the metal forming process. It is one of a forging process. So coming to the metal forming process, we can say simply it is a plastic deformation performed to change the dimensions, properties and the surface conditions by means of applying a mechanical pressure. So of course you all very familiar with this stress strain diagram. Here this point is called yield point, because whenever you are subjecting the material beyond this yield point, that will be going to the plastic deformation. So when you are subjecting the metal within the yield limit, then it can recover its original shape. That is called elastic deformation. Whereas plastic deformation is a permanent one. You cannot recover it. So here in the metal forming process, we are going to work on this region. That is, we are subjecting the material or metal flow to be occur above the yield point. Okay. So when you keep on applying the load, or what happened beyond this point, ultimate tensile strength is going to get broken. So our ultimate aim is to work on this region of the curve. That is, here only the material is subjected to the strain hardening or the plastic deformation. So I can say like the metal forming is a kind of a bulk deformation process where it involves the large amount of plastic deformation, and here the cross section of workpiece only changes without volume change. For example, if I am taking a bar of 15 cross 15 centimeter and by applying a mechanical force on it, I am just changing the cross section of it. For example, either from a square cross section, I am going to change it to either a rod or it's a rail, whatever may be it. Only the cross section of the workpiece changes without the volume change. So the total volume, I'm not removing any material, we are not removing any material, and then we are just changing the cross section of it. So the ratio of cross section by volume is very small, because the volume we are not changing it, the volume is higher, only the cross section changes. So we can say like the cross section area by the volume is ratio is very small. And for most of operation, hot working or warm working conditions are preferred, because you can heat the metal and the yield strength is decreased and the ductility also improved. So the less force is enough to change or to form the material to the required shape. So in the case of sheet metal forming, it is something different from the bulk deformation process, because already we are having a sheet. We are not going to elongate the length of the sheet. We are not changing the cross section of the workpiece, whereas we are just expecting the sheet metal to just change its shape. For example, the automobile car body, or you take some blank or embossing, where the cross section of the workpiece is, the thickness of the workpiece is not changed, whereas the shape is getting changes. So here the cross section area by the volume is very high. So here the sheet metal working is performed on less than 5 sheets or strip of coils, for using a separate tools are called stamping presses, drawing. You can see, you might have seen the utensils used in the kitchens. Some sheet metals are taken and it is formed into the deep drawn cups, like that. There are several applications of sheet metals. You can see the ducts, AC ducts, and this sheet metal forming is carried out in the cold working manner. We are not heating it to do it, because the less force is required to form the shape. And which manufacturing process is best or produces sound product? You know, now unit 1 you might have discussed different types of casting process, and unit 2 we are going to discuss about metal forming and machining. And obviously this metal forming is a very good, it produces a sound cast. So you might be wondering why it is. Let us see. See, for example, you take the crankshaft. So you make the same crankshaft using a cast piece from the casting as well as from the forging. Also, if you want, you can make it from the machining process also. Which one do you think withstands the higher the mechanical load? Okay, so here let us see the microscopically. For example, if you see the microstructure of that crankshaft made in a casting, okay, so you can see the grinds like this. That means what? There is no proper direction of grind flow, because the casting, we are preparing a mold and we are preparing a molten metal and we are pouring it, so it starts solidifying. So the new grinds are started forming it randomly from the boundary, and then so you are getting a randomized grind flow. Okay, whereas if we are taking a machining process, we are just removing the unwanted material, and then what happened, the flow lines are abruptly cut, and here there are chances for corrosion. Okay, since the flow lines are cut, when it is exposed to the atmosphere, the corrosion started happening over there. Whereas you just observe the grind flow in the forged piece, because we are making the metal to flow along the lines. Okay, so the metal flow takes place along the direction of the force applied, and because of that, the grind flow is taking along the shape of the boundary of the crankshaft. So it possesses the higher mechanical property like toughness and fatigue strength and high hardness strength. Always the metal forming process it produces a good product. Usually the crane hook, okay, the crane hook which is produced from the forged process, it withstand or carry a heavy load as compared to the crane hook made up of casting as well as the machining process. So as I said earlier, we are going to work on the metal above the yield point. That is, we are going to working on the plastic deformation region. So that means strain hardening takes place. Strain hardening is one of the strengthening mechanism where the grains present on the metal are subjected to get elongated. So when the metal is formed in the cold state, so there is no there is no recrystallization of the grain. So I'll come to this a little bit later. What about recrystallization, recovery of the grain, distortion and all. So when you are working on the cold state, what happened to that? The grains present in the metal are subjected to the elongate, or it is getting compressed because we have our heavy load, and the grains are getting distorted. And because of this distortion, it provides a great resistance, and then the hardness is getting increased. So that's why we are calling as a strain hardening. You just take the metal in a normal temperature and then apply a heavy load on it. So what happened to the grains present on the metal? It's get just distorted. The grains are distorted, and because of that there is a stress relief essential. So because of this, it offers a great resistance, and because of this, the hardness and the strength is getting increased. This is called strain hardening. So in order to overcome that, then if you are heating that cold work metal by just keeping it in a furnace or doing some heat treatment process like annealing, then what happens? The stresses are getting relieved, and then it comes to the recovery stage. Then new grains are formed. That is called recrystallization. New grains are formed in the recrystallization region. So this is an annealing heat treatment process. As I said earlier, there are 3 stages in the annealing heat treatment process, because always whenever you are doing a cold work product, that should be followed with some heat treatment process. Otherwise, it is internal residual stresses are very high here. So once you are doing cold working, means the normal temperature, you are just applying only the mechanical force. You are just trying to change the shape of the product. So the initial residual stresses are higher here. You see the grains are getting distorted, and once you are started heating it, and what happened? The stresses are started getting released. There the hardness and the strength is high, whereas the ductility is very low because the grains are getting elongated. Okay, so when you want to apply more force, then it is very difficult for you to get elongate or stretch the grains. So when you keep on increasing the temperature, what happened? At a point, the new grains are started forming at the expense of the distorted grains. That is called recrystallization. Recrystallization. New grains are getting generated. New grains are getting formed. But when you keep on continuing the material in the furnace or keep on increasing the temperature, what happened? The grains are started growing just by merging with one another. And once the grain started growing here, what happened to the strength? The strength are further, it is getting decreased. So that's a point you have to remember here. So in the heat treatment process, there is a recovery, recrystallization and the grain growth. So what do you mean by recrystallization? It is a minimum temperature at which the completed recrystallization of the gold metal occurs within a specified period of approximately 1 hour. That is, all the distorted grains are just sorted into the new grains. The new grains are started formed into the metal piece at that temperature within 1 hour. That temperature is called recrystallization temperature. So always a recrystallization strength temperature, it decreases the strength but increases the ductility, because when the temperature of the metal increases, the ductility also increases. You can easily draw the bar, isn't it? So if you are working above the recrystallization temperature, then we are calling as a hot working process. When you are working on the metal below the recrystallization temperature, we are calling it as a cold working process. So it involves the replacement of cold work structure by a new set of strain-free, approximately equiaxial grains to replace all deformed crystals. That's why even if you are working on the cold condition, that is in the normal temperature, by applying a mechanical force, the grains present in that are getting distorted, and in order to relieve the internal stress, you should follow that procedure with some cold working process, some heat treatment process. So when you are doing a heat treatment process, all the stress are getting released and new grains are equiaxial grains are formed. So how do you identify the recrystallization temperature of a metal? So it always depends upon the amount of cold work of metal it already received, and the higher the cold work, if you are doing more work on it, the recrystallization temperature is getting decreased. For example, in a general word, the recrystallization temperature of the given metal, it varies from 0.3 to 0.5 of the melting point of the metal. So it depends for different metal. For example, you take iron or a steel or aluminium or whatever may be, copper, lead, any metal, depending upon the melting point of the metal, the recrystallization temperature, it varies. For a pure metal other than alloy, generally it is a 0.3 or 1/3 of the melting point. For alloy, it is 0.5 times of the melting temperature in Kelvin. For example, for lead and tin, you know the melting point is at the room temperature, so you have the recrystallization temperature is below the room temperature. For a material like cadmium or zinc, it is approximately the room temperature. For the iron, it is around 450 degrees C. For the steel, it is around 1000 degrees C. So finally, the initial grain size lower the recrystallization temperature. So the hot working or cold working, it depends upon the metal on which what you are working. For example, as I said earlier, for the lead and tin, it is below the room temperature. Okay, even if you are working on that, then we are calling it as a hot work. Okay, so the mechanical working of metal, to recap it, I am saying it again, the mechanical working of metal below its recrystallization temperature we are calling as a cold working, and if we are working above the recrystallization temperature of the metal, we are calling as a hot working. So let us see what is the advantage of this cold working process. Here, we are getting a better accuracy and close tolerance. Since we are not working on the hot metal, we can bring the shape easily. Not the shape I am saying. If you are doing a hot working, what happens? If you are heating a metal, the scales are started forming on it. So the surface finish, you are having a layer of oxides. So you have to remove it. Whereas in the case of cold working, it is not there. So better accuracy is there. And what is another advantage of the drawback of a cold working? Since the metal is very hot, it is very difficult to handle. We cannot ensure what is the shape you have produced, isn't it? If you are doing especially in the manually. So by that time, cold working is having a better accuracy, better surface finish, and we are doing a strain hardening, and that strain hardening, you are destroying the grains, and because of that, what happened, the strength and the hardness is increasing, and the grain flow also, whatever it is happening in the cold working is very desirable here. And always there is a directional property, and no heating is required, so the energy required to do or form the metal is less. But what are the drawbacks here? You have to apply heavy force because the ductility is very less in the normal temperature. When you are heating it, the ductility may be increasing. So because of that, you need a equipment with a higher force and power is required, and the surface of the starting workpiece must be, so first you have to clean the surface, isn't it? You might be working on the basic workshop, just you will be doing a filing and then removing the dirts and the oils, and then the ductility and the strain hardening limit amount of forming that can be done, and the metal must be annealed to further deformation. I told you why annealing is needed, because the grains present on the metal, when you are heating it, when you are beating it, then what happens? The grain structure are getting elongated or grains are distorted. In order to relieve the internal stress, you have to do the annealing heat treatment process. And some metals which are not simply ductile, not able to do it in the cold work manner. So hot working means you are going to work on the metal above the recrystallization temperature. So you have to heat the metal above 0.5 Tm to 0.7 Tm and then start working it. Then we are calling as a hot working. So what happened? The porosity or some inclusions are there in the metal. When you are heating it, what happened? The metal starts flowing. So then the porosity is removed and the grains are getting elongated, as well as new grains are started forming. So the grain structure of the metal is defined because recrystallization is the point where the new grains are started forming. So the impurities like slag are squeezed into fibers and distributed throughout the metal. So it is not present on only one point where it may be produced. So it gets squeezed and distributed throughout the metal. So the mechanical property of toughness, percentage of elongation, and percentage reduction in the area, resistance to shock vibrations are improved because of the refinement of times. So there is no strain hardening takes place here. And drawback is the process is not properly carried out. It affects the tensile strength. So the heat treatment should be proper and you have to heat the metal on the proper temperature. So less force is required. That's one advantage because the energies may be same. Because there only you are applying through the mechanical energy. Here you are just using the heat energy, then you are applying a mechanical energy. So the equipment needed for applying a mechanical energy may be less. But no residual stresses because we are just heating it, improving its activity, and then we are applying. Drawback is it is also requiring some expensive tools and it produces poor finish because of the scaling and oxidation. So because of that, we may not find the close tolerance. And something called warm processing. What do you mean by warm forming? So because if you are working below the recrystallization temperature, we are calling as a cold working process. If you are heating above the recrystallization temperature, we are calling as a hot working process. So what happened in between? So we can take the advantage of both. Am I right? So that's why we are using as a we are naming as a warm processing process. Whenever you are working on the metal, the temperature in between 0.3 Tm to 0.5 Tm. Tm is a melting point of the metal. Then we are calling as a warm processing. So compared to the cold forming, it reduces the load as well as increases the ductility. So the scaling formation is somewhat less here. So better dimensional properties happening over here. And one more forming process is called isothermal forming because in hot working what we are doing going to do, we are heating the metal and then we are keeping it on the die which is at the room temperature. By the time what happened, the hot metal is getting in contact with the cold die set, am I right, or anvil. So to avoid that, we are just going to heat the metal surface also. So the dies and toolings also must be heated to the work temperature, sacrificing the die life. So that we are calling as isothermal forming because the uniform you are getting a uniform deformation and all around the environment. So we are going to discuss about 4 important techniques, namely rolling, forging, extrusion and drawing in the forthcoming classes. So let us see in the next class. Thank you.